Hi guys. Actually, as you know that this job is for electrical integration engineer. So what do we expect from you guys is that you need to have a good know-how about the electrical distribution as well as the electrical transmission systems. So this is a 10-day trial period for you guys in which we will be providing you with the resources such as the YouTube videos that we are building on Ripple Engineer platform. And what you guys need to do on your end is that you need to understand these videos. You need to refresh your knowledge because many of our previous candidates were having difficulty in managing the designing of the power systems. So what we guys understood was that yes, time is not always beneficial for all of us. So we presented a new series of YouTube videos, and this is for the first time because the output from the candidates was very pathetic. So now what you guys is you will listen to each video every day that I will be sending to you, and then you will be filling out the Google form. And remember that no chat GPT in it. We just want your pure critical thinking, logical reasoning, and we want to test your creativity. So without wasting any further time, what are the types of distribution networks? There are three main types: radial, ring main, and interconnected. So today we are diving into how electricity gets from substations to your homes and businesses through these distribution networks. So I will look at the radial system, ring main system, and interconnected system, but from the perspective of the US grid. Remember, so you will see how these systems work in real life, from rural America to big cities like New York, Wisconsin, Tennessee, and Texas, and all other 50 states, as we love all the 50 states. And what makes the US grid one of the most advanced, yet also most defenseless in the world. So let's jump in. So, what I think is that the radial system is the simplest form of distribution because power flows in just one direction from the substation to the consumers. The advantages are that it is low cost, easy to design, and great for short distances. That is why in the US, rural distribution networks, for example, in parts of the Midwest, often use radial feeders at 12.47 kilowatts, or, or you can say 25 kilowatts also in some areas, because we need to take into account all the states. So the drawbacks are quite fascinating because they are not reliable. They are poor reliability. So if a storm or a fallen tree takes down one section, every customer downstream loses power. We see this all the time during hurricane season in Florida, like we witnessed, and in the winter ice storms in Texas, where long radial feeders get knocked out, leaving entire rural communities in the dark. So the voltage regulation is also a problem. Customers at the far end of a radial line may see low voltages during peak summer demand when air conditioners are blasting. So what I want you to see is think and animate in your mind the loop of transformers connected in a ring. So what you see is that the ring main system. So the ring main system, I just dive into the details. I just present my slides. So before we say into the ring main system, I just want to elaborate that the main features of the radial system are that this substation to each area consists of a separate feeder. What does it mean is that there's a separate individual feeder from the substation to each area. If you're in Tennessee and it's some portion of Tennessee and some other portion of Tennessee, there would be separate feeders from the substation to each area. So the feeds it feeds power to a distributor in one direction only. Design, as I said, is simple, low cost, and easier to implement, used for a short distance distribution system. And the drawbacks I have only really described as they are low reliability. I have taught each and everything, but I want to again explain so that you can read and revise your concepts. So the end of the distributor nearest to the feeding point will be heavily loaded. What does it mean is that the feeding point will be heavily loaded at the end of the nearest distributor, that is nearest to the feeding point. So next we move on. So what here you are getting? So this is basically a conventional, we can say a conventional radial system. What does a conventional radial system tells you about? So conventional radial system, basically on the left diagram, it is a single feeder that comes from the substation and goes straight into the distributor. Single feeder that comes from the substation and goes straight into the distributor line. So the distributor, the loads are directly tapped from the distributor at different points. The voltage levels, I assume that the feeder and the distributor are at the same voltage level. No explicit transformer I have shown here, but the operation tells us that the substation feeds directly into the distribution line and the loads are connected at points along the distribution. So this is the basic radial system used for short distance and small towns or rural feeders. The right diagram over here, you can say the feeder, again one feeder comes out of the substation, the step down transformer. Now you have to notice the zigzag symbol. This is the you can say the 11 kV or 400 volt comma, you can say, and there is written that comma 230 volts. So this is a distribution transformer. It steps down the voltage from 11 kV medium voltage distribution to 400 watt. So it steps down. And this is practicality. You cannot directly feed 11 kV into the distributor side. You have to step down it. So it step down the voltage from 11 to 400 watt. And after, so what does the distributor do is over here, the distributor after the transformer has come into action and has punched down the voltage, the distributor loads are tapped at consumer voltage level. So this is the practical radial distribution system, because in reality, you can't supply 11 kV directly to houses. You have to step it down to 400 slash 230 volt using distribution transformers located along the radial feeder. So what I say is that you guys need to think about these things in a very detailed manner, that the ring main system, the primaries of distribution transformer, in case of ring main system, the primaries are connected in a loop and supplied by a substation from one end. It means each distribution transformer has two different ways to connect with the substation. I again repeat that in the ring main system, the primaries of distribution transformers are connected in a loop. You can say, what do I mean by loop? Just like the clock needle, it moves in a loop. And you must have studied about Kirchhoff's laws in a loop. You try to recall it. And most of you are quite intelligent. They know what a loop means. So I'm just diving into the baby steps right now. So it means each distribution transformer has two different ways to connect with the substation. Next, moving on, you can first of all, before moving, I need to know that you must be knowing about feeders later than service mains. So these are quite important. And if you present any hesitation, just do let me know in the comments and we will either slow down or pace up. Second are the interconnected system. Third are the interconnected system. So before I deal with the interconnected system, one important crucial thing about the ring main system I want to elaborate here is that you know that after studying the radial system, what do you think that is something better than radial system? So why we are studying ring main system? There is a specific reason for this. So here the distribution transformers are connected in a loop, as I earlier said, and power can flow from two directions. Yes, we all know that. But this makes it more reliable than the radial system. If one section of the loop fails, the other side can still feed customers. So in the USA, ring configurations are common in urban areas where reliability is critical. Think downtown Chicago or New York City. So utilities like Con Edison in New York use ring mains and underground networks to ensure customers don't go dark if one cable fails. This is the most important thing. So most protection engineers, most integration engineers fail to answer these questions in the viva. When I ask them that what do you think, where is the defining wall between ring main systems and radial system, they fail in the interviews. They don't know. They don't give the example. So I want you to be enthusiastic in the interviews as well as when you are filling out the assessments. So protection, there will be 10 assessments, short assessments, one question, and you have to elaborate. It will take only 3 minutes and probably 50 seconds, not more than this. So protection is more advanced. Directional relays, circuit breakers, and reclosers are used to isolate only the faulty section. You must have studied in your power system protection course about the relays. So keeping most of the loop energized in this way, because circuit breakers come directional relays and the reclosers that are used to isolate the faulty section. So more security is provided. Now I present the interconnected system. This is the final system. So what do you think about it? So interconnected distribution system is a loop that is supplied by more than one substation or generating stations at different points. This is also called grid distribution system. So what do I mean by grid distribution system? Try to imagine that in this case, multiple substations and even generating stations feed the same distribution loop from different points. What makes it more differentiable than others? It is highly reliable, reduces the reserve generation, and it enhances the efficiency. So the US power system is actually split into three major interconnection: the Eastern interconnection, the Western interconnection, and the Texas interconnection. So the design means if one generator or line goes out, others can often take over. But the downside must not be forgotten, as it is highly vulnerable. It is vulnerable like others because vulnerability is on the low side, but it exists. Highly vulnerable is what? Radial system. But over here, a good example quote here, I always quote that the Northeast blackout of 2003, which left 50 million people without power across the US and Canada. Why? Why people suffer? One fault in Ohio cascaded through the interconnected system because of poor coordination and grid overload. Now, the technical considerations I must note down here, and when engineers design, when you will be designing our distribution systems, you must consider uniformly distributed loads, street lighting in suburban neighborhoods, increasing the loads. New subdivisions must be there where demand grows over time. Lumped loads, large factories, data centers or hospitals connected at one point. OpenAI are using data centers, and we need to provide them with a good distribution system. And you will be the guys who will be designing this whole stuff. So the voltage variation is regulated by the ANSI C84 and one standard, which keeps customer voltage within the tolerance plus minus 5%. So utilities use voltage regulators, capacitor banks, and smart meters to maintain this balance. Power losses and voltage drops are especially critical in long rural feeders, which is why utilities like Pacific Gas and Electric in California face big challenges with wildfire prevention while maintaining voltage control. So, what do you think about the protection and reliability? So the US utilities measure reliability using SAIDI and SAFE indices. For example, utilities in states like California, Louisiana often report higher outage duration due to storms and wildfires, while utilities in New York and New Jersey perform better because of more robust ring and network distribution. So you must keep this into mind that the future of distribution in the US is moving toward smart grids and microgrids. The smart meters and advanced communication systems allow utilities to monitor loads in real time. The microgrids are being deployed in universities, military bases, even, and in universities and hospitals. For example, the University of California, UC San Diego. So the microgrid supplies most of its campus with local renewable energy like solar and natural gas generation. Renewable integration is quite huge. Energy storage like Tesla's megapacks in Texas are being tied into the grid to improve resilience. So, what do you think is That if we dive deeper, that the interconnected system are reliable, and any area that is fed from one generating station during peak load hours can be fed from the other generating station. So this reduces the reserve power capacity and increases efficiency of the system. I repeat it, any area that is being from one generation station during peak load hours can be fed from the other generating station. Any area, for example, it is Chicago, fed from one generating station that is located in Chicago during peak load hour, that is from 7 to 11. Most power engineers know this, can be fed from the other generating station. And this reduces the reserve power capacity and increases the efficiency of the system. So the most important considerations, I again repeat, that the concept of uniformly distributed load must be kept in mind, into mind, and the increasing load and the lump load on our distribution. The power loss and voltage drop, and I earlier mentioned plus minus 5%. Now, what do you think about the demand interval, about the average demand, about the maximum demand, load curvation, duration curve, and the coincident demand, the diversified demand, non-coincident demand, or non-diversified demand, diversity factor. So what do you think about these things? So the load average over a specific period of time is known as demand. Load can be in kilowatts. It can be in kilowatt ampere resistance, like we know reactive power, kilowatt ampere or ampere. So they must include the time interval. So one of my great professor used to say that the reactive power, just like a person hopping from one sofa to another, it doesn't play an active role. It is just reactive. It is just required to maintain the equilibrium. Just this thing. So you must include the time interval, that demand is the load averaged over a specific period of time, and the load is in kilowatt ampere resistance, kilowatt ampere or ampere. So you must include the time interval, 15 minutes. Why time interval? Because in the future, load forecasting will be done to estimate how much load is being carried when designing the distribution systems. So in this chart, I present you about it. The 15 minute kilowatt demand is 4.8 kilowatt. So what do you think is that the basic definitions are the maximum demand, the greatest of all demands that occur during a specific time. You must include the demand interval, period, and units, because it's the greatest of all demands that occur during a specific time. The 15-minute maximum kilowatt demand for the day I show you here was 6.18 maximum demand. So these are the charts, these histograms, bar charts, these are the data visualizations that we use to determine the correct figures and to improve our power system. So the average demand is the average of the demand over a specified period, day, week, month, etc. So remember, you must include demand interval, period, and unit. The 15-minute average kilowatt demand for the day is 2.46 kilowatt. So what I have done here is I have calculated that the total energy, I counted the total energy from where? Yes, from the it was 58.96. How it came to be? Just calculated that we are taking from you can say 23, 21, so 144 and 44, and just add 11 into it, and probably 44, and you can add 1230 into it. So it for 1230 or 10.45 add in it. So it will probably make 58.96. And so what you guys need to do is that when you divide 58.96 over 24, you get 2.46 kilowatt. So just calculate it at how we have got 2.46. It's quite simple. What I mean to say here is that how we are calculating the values. So the load curve 1 over 2, maximum 15-minute demand, load curve 2 by 2 example is also over here. So it is a second example. So what does these examples show? Average demand, maximum 15-minute demand, maximum 30 minutes. So these are the time frames that in this time period, how much load we were witnessing. So these are how the peak hours determined. So the load duration curve and peaks of demand are arranged in descending order, going downward. The resulting curve is known as duration curve. So the low duration curve, when the peak of demand are arranged in descending order, the low duration curves can be daily, weekly, monthly, or annual, and it is up to the power distribution engineer with the consensus of the board of directors. For example, if the curve is a plot of all the 8,760 hourly loads during the year, it is called annual load duration curve. If the curve is a plot of all the 8,760 hourly loads during the year, it is called annual load and duration curve. You cannot change eight from 8,760 to 8,761. No, this is not the thing. You need to be precise. So the load factor is defined as the ratio of the average demand to the maximum demand. Average demand to the maximum demand over a period of time. Average load over peak load. Simply, this is the maximum load can be described as peak load. So in many ways, load factor gives an indication of how well the utilities facilities are being utilized. From the utility standpoint, the optimal load factor would be 1, since the system has to be designed to handle the maximum demand. So the load factor example, you can go through it. It is the average 15-minute kilowatt demand. And now, if it is the average, what we guys need to do is, so we have studied about the peak demand, average demand, and the load factor. So now the load factor variation has been observed here, that typically in a typical home, the load factor varies from 30 to 60%, while in a typical commercial building, load factor fluctuates from 20 to 60%, and in an industrial zone, the load factors have somewhat like we occasionally observe 90+% load factor. So the load factor vary continuously with the types of loads and the operating schedules. So some industrial loads dip to 20% or even lower, while on the other hand, the commercial buildings commonly sees 40 to 70%. And the seasonal swings, what do you mean by seasonal swings? In the summer season, when continuously electrical cooling is observed, and in the extreme winters, when the heating systems are required. So what you have to observe is that these type of swings have particular effect on the load factor. If you are in extreme weather season, the load factor would depend upon the consumption of the energy, and indicates how long the peak demand was sustained. For example, kilowatt per hour into 100% over peak kilowatt into number of hours in billing period. So I take an example that 100 kilowatt peak demand, 45,000 kilowatt hour consumed 31 days, the load factor would be 60.5%. So in the non-coincident demands, you say that if 4 customers connected with a distribution transformer, I see here that the peak demand, here the peak demand, here the peak demand, and here the peak demand. The 4 peak demands of 4 different customers vary continuously. And the maximum non-coincident demand, what does it mean? That this demand is not usually occasionally observed, but in some different scenario, today it is observed, except it is quite extraordinary day. So it is 24.98 kilowatt of the 4 customers. So in a diversified demand environment, what do we say? That sum of demands imposed by a group of loads over a particular period, and the maximum diversified demand occurs at 1730, the 24-hour clock, that has a value of 16.16 kilowatts. So you must think that this is the maximum demand that does not occur at the same time as any one of the individual demands, nor is this maximum demand the sum of the individual maximum demands. So the maximum non-coincident demand, as I earlier said, for a group of loads is the sum of the individual maximum demands without any restriction that they occur at the same time. I repeat that for consider an example that there are a group of loads of 4 customers, and when I sum the 4 customers up, the individual maximum demands and with the maximum non-coincident demand would be the individual maximum demand without any restriction that they can occur at the same time. Similarly, maximum diversified demand is the maximum of the sum of the demands imposed by a group of loads over a particular period. The diversity factor is also the ratio of the maximum non-coincident demand of a group of customers to the maximum diversified demand of the group. So, with reference to the transformer serving four customers, the diversity factor of the four customers would be, you can say, it would be 24.98 divided by 16.16, and it would be 1.5458. Now you must observe the impact of the number of customers on the diversity factor. So this table presented to you presents a broader picture of how you can say that the non-coincident demand, the coincident demand, the maximum non-coincident demand, the load factor, how they are contributing to this graph. And the line observed, the result is a constant value. So this constant value tells us about the 3.2 value obtained from the number of customers and the diversity factor. The demand factor, always remember, it is the maximum demand over total collected load. Maximum demand over total collected load. So the demand factor can be defined for an individual customer. In order to determine the demand factor, the total connected load of the customer need to be known. The total connected, what does it mean? That how many load, how many customers are associated, and the total load that they are consuming. The total connected load will be the sum of the ratings of all the electrical devices at the customer's location. The demand factor gives an indication of the percentage of the electrical devices that are on when the maximum demand occurs. So you can see that in this over here, what there is a compute demand factor. Well, the compute demand factor. So this example tells us how to compute the demand factor for the given data if the system maximum demand is 35 kilowatt. To calculate this, consider the parameters. There is house 1. House 1 contains the connected load 30 kilowatt. The individual maximum demand is 25 kilowatt, and the demand factor is obtained by dividing the collected load over the individual maximum demands, and you get 0.833. House 2 collected load divided by individual maximum demand, you get 0.8. House 3 collected load divided by the individual maximum demand, you get 0.875. You add the individual maximum demands, 35 divided by individual maximum demands, and you get 0.37. Now the question is how we have obtained 35. 30 plus 40, 70, 70 plus 25, 95. So what we take an average, mean average, and this is how we get the 35 value. Now what we have to do is, there are the example B. In the example B, there are three consumers of electricity that possesses load requirements at different times. Consumer 1 has maximum demand of 5 kilowatt at 6 p.m., demand of 3 kilowatt at 7 p.m., 5 kilowatt at 11 a.m., and a load of 2 kilowatt at 7 p.m., and an average load of 12 watt. So the consumer 3 has average load of 1 kilowatt and maximum demand of 3 kilowatt at 7 p.m. Now I determine the diversity factor in load factor and the average load and load factor of combined load. And the customer 1 has the maximum demand 5 kilowatt, demand 3 kilowatt at 7 p.m. of customer 1, and load factor is equal to 20%. The formula is quite clear. The diversity factor is equal to sum all the demands 5 plus 5 plus 3 of the three customers. You have done this, Susan. Next step is demand. Demand, what type of demand? This demand you have to figure out. This demand needs to be figured out, and this is equal to 8. I will tell you, but I don't want just to spoon feed. You have to think that how this 8 has been observed. Step 2 is, what are the load factors? So the load factors are quite clear. Just simply divide 1.2 divided by 5 equal to 0.24. Average load would be, you can simply 0.2 multiplied by 5 plus 1.2 plus 1, you get 3.2 kilowatt. And combined load factor is 3.2 divided by 8 is equal to 0.4. So thank you guys. In the next video, we will be presenting a broader picture of all these principles in a practical way. So till that time, wait for the Google form and comment below how you are liking and what further knowledge you want to obtain. And please subscribe the button, share and like. Thank you. You are all awesome people.